Okay, my outstanding friends, not the greatest news, but I'm reporting on what I see and my opinion of it and my evidence to support the things that I have claimed about the Earth's increasing temperature and how it's causing huge earthquakes, and it's going to have a serious impact on the Earth. Now, this is saying Earth's oceans are boiling, and it's worse than we thought. The increase in temperature is just staggering. And this causes biology, which is what everything is on top of biology. And when that biology begins to rot, literally in the ground because of the warmth, it will expand, the gases will expand, and cracks will open in the Earth. All right, this is my claim. The entire Earth is biological, and underneath the surface of the Earth, that biology has not decayed and decomposed completely. It's what's called anaerobic. There's no oxygen down there to take that heat out. So that gaseous expansion from the breakdown of biology creates gases, primarily methane gases. And it is expanding, and the Earth is starting to crack open. Rare footage shows a fault line tearing open. Game changer for earthquake. This is Kyoto University, and this was Myanmar. I think that's how you pronounce it. And I looked at this carefully, and it's because of biology. Okay, this is overheating the oceans, and they claim it's because of the greenhouse gases. Well, that is true, but it's not the gases they're thinking of. It's not carbon dioxide capturing extra heat. It's that the heat cannot get out. The problem starts way out here at the ionosphere, where it scrubs space. And I'm going to tell you right now, space is so saturated you can't even imagine with particles. Now here's the key. Let's just cut right to the chase. This is what happened. Record-breaking intensity and spread of the heat globally. Team found that 2023 surpassed all previous records for intensity, length, and coverage. The events persisted 4 times longer than the historical average and spread across 96% of the world's oceans. And then it goes through all of the different ones that were particularly extreme heat. The North Atlantic, tropical Eastern Pacific, North Pacific, I mean, it's everywhere. Together made up 90% of the total ocean. So 90% is negatively affected by this because it's extreme heat, and they're finding cracks in the ocean floor because the same stuff happens down here. It's biological decomposition in anaerobic conditions. There's some very basic physics and chemistry involved here. You got aerobic, which means with oxygen, and then you got anaerobic decomposition, it means without oxygen. Totally different outcomes. It's different primarily in the presence of the absence of oxygen. The aerobic decomposition, which is out in the air and it just sort of just decays, is generally faster, more efficient in reducing the pathogens just dying. Anaerobic, now this is without oxygen, buried stuff. Anaerobic decomposition, on the other hand, occurs without oxygen in the ground and produces methane, a potent greenhouse gas, as a byproduct. And when stuff gets warmer, it decays quicker and creates huge amounts of methane, which is what's happening right now. Methane is much more devastating to the environment than carbon dioxide. But everything is swelling the environment out like this, the atmosphere, which means we're scrubbing harder. I'm just going to tell you the end result here is that we're scrubbing much harder now against all the particles that are in space. And you say, oh no, Roger, space is a vacuum. I say, that's insanity. Space is 100% saturated with particles. Everything that's given off from the sun is a particle. They're everywhere. And every one of the other ones that do too. And you want to see what they actually look like in space? This is the scrub zone. the more that goes out, it's just like scrubbing harder and harder and harder against all these particles. And it's overcharging the Earth with heat. Right now, we're overcharged. And we're having fires and tornadoes and hurricanes and floods and earthquakes. The Earth is being wrenched. I'm sorry to say it. Like I said, it's not going to be good news. You see this? This is what space really looks like. All this stuff is out there. And the guy I'm working now with, Mason, he has a Newtonian telescope, reflective, 5-inch, all kinds of stuff. And he's found a way to remove the things that they build into these telescopes to remove this stuff. They don't want you seeing all this background stuff. They want you only seeing certain. It's like a Zener diode. You probably don't know what that is, but there's a threshold. So all of this stuff, he found a way to see this stuff that's always been suppressed with these layers of filters. And they filter out this stuff that they don't want you to see, but it's all out there. And he removed all this layering that they had on there to suppress these effects so that you could only see these kind of things. But all this stuff is in the background. Now, that's Mason. I mean, the stuff he sent me is absolutely stunning. Stunning, and stunning-er than stunning. I would say stunning-est. You want to see something? Look at this. That's Saturn. This guy is, I got to be honest with you, I don't like to belittle anybody, but as far as I'm concerned, he's way ahead of NASA. Look at that. And here, this is my dipoles. They're everywhere. They're everywhere, 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 everywhere. And this is a moon, and these are moons around Saturn. It has a zillion moons, and they're all in the names of gods and goddesses. We got a lot of thinking to do, my friends. Okay, if you've been following me at all, you know about dipole electron flood theory. I always knew there was dipoles, but I didn't understand the actual configuration and how these particles can separate. And this is what my current feeling of a proton is. It's inside of a whole batch of glowy little energetic particles. There's the dark matter is there, and it separates and goes to the center, and it's completely surrounded by the white. And we use light, which is only one black and one of these together. That's what, well, light is two of those back to back. Here's what it comes out to be. These are the only two particles that exist. This is atomic vapor. It's actually subatomic vapor. It is the vapor of particles that combines together and has 1839 or 40 or so to make a proton. It's an uneven number, 1839, 1841, whatever, of these two together. And this is what it is. We can separate those, and we did. And two of them together make what they call a gluon. I agree with that. But the dark and the white is a dipole electron. And back to back make photons. There's some changes to science. And we're going to go through that. All right, so you just saw space is saturated with particles. We're spinning and being torn through the, well, hold on a second. All right, this is what is happening with our solar system. It's on the arm of the Milky Way being pulled this way. All the planets are following the sun, which is the mass that is pulling all of these particles along with them, which happen to be our planets. And they're scrubbing, and I can see the scrub coming off of there, and I can show you that scrub. All right, this is the nature of our universe. Everything is everywhere. This has been filtered out. You would see these stars and so forth maybe as in the galaxies, but these are the dark, you see that? That's a dipole. These are dipoles where you see the light and the dark near each other. You see something's going on with that. Everything is a dipole. And in nature, that's all there is dipoles. And out in space, that's what we have to plow through. And that's what's scrubbing our ionosphere and turning it very, very hot out there. I'll show you the temperatures. All right, first of all, here we are in a galaxy spinning around like this pretty fast, and as it gets closer and closer to the center, it gets more and more crushed. Now, we could be in a dense spot or not dense spot. We're in what they call the Milky Way. I don't know what the galaxy this is, but they all happen to do the same thing. They spiral inward because the matter condenses inside. The dark matter goes together, and the white chases it. That's what electricity is, white chasing the black. All right, so I think I showed you this, where our outside atmosphere is scrubbing the atmosphere that's in space. I showed you the galaxy spinning, which we are somewhere in this mess spinning around. This is what space is, saturated with particles. And this is the end result. We're scrubbing through all those particles too. This is the exosphere. It's outside. There's very few particles out there. I agree. It's certainly nothing like down here. Right here, it's extremely saturated with only the white particles. There's no dark matter in here, almost none. And it says in this appeared northern lights, at high temperature, 1500 Celsius. It's like 2500 degrees out there or more. And it goes much higher than that, is what I've been told. However, they look at this as almost like a vacuum because there's no dark particles out here. Where did dark particles go? They got pushed down here. Well, what happened down here? It went right at this layer here. This is the dipole. There's the white layer. Here's the black layer. Minus 80 degrees Celsius. It's 120 degrees or something below zero. So it goes from 2000 plus up to minus 100 and something. Then it goes hot again below that. That's what your dipoles are. Hot, cold, hot, and that's where we are. And it keeps pushing the heat down into the Earth. It's not going to go back out. It's being scrubbed down in here. They think it'll just float into space. It doesn't work that way. We're scrubbing through that like rolling down a road, only scrubbing harder and harder because it's getting bigger and bigger. All right, here's my proof of what I'm saying. You see these red spots? This is a solar eclipse. All right, the moon covers the whole disk of the sun, so you don't get blinded by the light. You see these three spots? The sun must be moving this way, traveling that direction, I would say. This is sloughed off radiation. All right, you see it's sort of sloughing off here. This is scrubbing in. Three spots. And they keep each other away from each other because of their own magnetic intensity. This just sort of fluffs off and rolls off the side and makes a stream backwards. This crushes in. That's the pole. And of course, this is the moon, so it's just blocking the light. Now, way out here is the corona. Well, what is the corona? The corona is where the heat is the highest. On the surface of the sun, which is behind, obviously, the moon, the surface of the sun is only 10,000 degrees approximately. Way out here, it's millions. Millions. And guess what? On our Earth, it's 100 plus or so, globally, 100-ish. Way out at the ionosphere, it's thousands and thousands of degrees. The temperature is being pushed in. It's not that it can't escape, it's being pushed in. And the more we push out with burning and all of these fires that are going on, and burn, baby, burn, combust, pump more oil and gas, every time you burn a molecule and turn it into energy, it expands as a gas, and it turns into enormous, huge amounts of space it takes, which just pushes the envelope outwards. All right, I'm not going to get deep into this, but it's very, very simple. When you scrub particles against other particles, you tear them apart. What they are creating is these negative ions, torn apart particles, and then they're spitting them out into space. They're scrubbing against our particles that are on our surface, which is nothing more than the electron part. The negative part is out there. And then below that comes the dark matter. So they're scrubbing their extreme particles against our extreme, heat against heat. Anytime field against field, you got energy. Whenever you've got energy, you can actually see them with this new stuff. I've got guys now that are doing stuff with photography that's just off the charts. It makes NASA not look too good, I got to be honest with you. All right, like I said, I've been working with guys for many years now. They're unbelievable. This was Rod Warren capturing actual photon in flight and then watching the photon explode. All right, here's that photon coming down. Accelerating and exploding. That photon was this photon right here. Or, you know, it was a photon. You see how that one's glowy and that one's not so glowy? This one is coming forward and concussing with all the other particles that are in the air. This one is protected by the black dark matter. It's this particle right here. So this one is taking the brunt of the impact at this moment. And it's glowing and it will go clip. That one will come to the front. This one will roll to the back, and they just keep doing that. And it spins up and down. It's always a straight up and down. Even if it was going on that angle, it would spin this like that. It wouldn't spin, you know, like that. All right, that's why they call it upspin and downspin. And that's exactly what you're seeing there. Now, what happened at the Venturi, which is here? Well, at the Venturi, the particles split. The black stayed behind, and the white squirted through. You can't see it because it's blinding luminosity here, which means a lot more energy. And then the black, somehow there's extra blacks or somewhere, they coming in over here. I don't think these ones jumped over. They're talking about, you know, they stay together no matter across the universe. This doesn't make any sense whatsoever. I can see them splitting apart here, and I can see them coming back together here. And when they come back together, they create Higgs fields. And the actual fact is, they start out as Higgs fields. You see that? That looks exactly like what comes out the other end. You see it coming over here? It starts like this, then it accelerates, and then when it comes back together just like that. And right here, this is a subatomic nuclear explosion. The particles split. The muon neutrino and electron neutrino created muons, which is the black balls, and electron showers, which is the electron glowy part. It's quite obvious. So now that we've gotten past understanding what everything's made of, we can start to look at why are we overheating? And what is heat? What's heat made out of? I know what it is, and you will too. All right, I'm just going to cruise through these. You saw this, this is at the tiniest microscopic scale, but it's as above, so below, and as so below. And these are the particles accelerating, and they create a particle and a wave, and the wave is all these other particles' fields are interacting. So it comes just like a boat making a wave. And this is actually where CERN agrees. What we did is this. We did exactly what they want. The muon neutrino and electron neutrino together split. The muon goes on its own, electron showers. And that's because it's in Cherenkov radiation. All right, and that's what we did. And it came back together here, and they fused back together at about this distance. And they grab all the black ones they can find. And it starts off just like a Higgs field, and it ends up just like a Higgs field. All right, I'm just going to cruise through these. This is from Mason, absolutely stunning. And we just started working together, so let's see how this goes. But these are all the dipoles, and these are all the fields. And you can see this using CMOS, complementary metal oxide silicates. Here's another one of basically the same area. And he's got a way of working with the particles, with the frequencies. I don't know. He's way ahead of me. This here is, look at that. Look at that. That's Saturn. And we got the blue is the more energetic, and red is less energetic. These are dipoles. And there's, why it's, I don't know. I guess, I don't know. I just don't know. But I'm seeing this, I'm certainly seeing a dipole. If you don't see a dipole there, then you better go to get some eyeball tests. What else? This is that same shot. There's dipoles, it's got moons. And a lot of them. I can't remember how many, but they're all named for gods. I think I might have already talked about that. Here's another one. Now, all of this stuff in the background, I said to him, I said, what the hell is all that stuff? He says, well, that's the stuff they filter out. They put in these little things to say, keep all that stuff away, because it obscures all the good stuff. I guess that's the way I'm taking it. Maybe I got it wrong, but he removed the filters. And that's why he's getting this. You take all the filters out and say, give me everything that's out there. Don't hide it. Yikes, run for your life. All right, I found this extremely interesting. This is our moon, and this is a brighter glow than here. You see the darkness here? You see how bright it is here? You see all these little dots? It looks like there's a whole ring of things right around the moon, and they are being illuminated because of the pushing. There's something there. You don't see them, but every one of these is a dipole. Every one of those little things is a dipole. What is it? Is it? Those are too big to be light particles, I would say. This is the moon. When I'm in my realm, I'm down in these little tiny particles, and yes, you could say, well, but something's out here. That's something, and it's not little. I would say they're not as little. They're not tiny. I don't know what it is. Whether they're just somehow fields that are showing up, but you can see this is the side that's white and that's the side that's dark. We got a lot of thinking to do. This is the side that glows a lot brighter with the blue than this side. And Dylan found the same thing in his shots, which is right here. You see the moon? It's very blue here. It's going this direction, I believe, crushing the light. But what does he see here? He found some other stuff that, yikes. This is years ago. This is about 4 or 5 years ago. I got these from Dylan. I never got any other word from him. I hope he's okay. But everything's dipole. So what is this? Look at that. Plus, this is on top of the moon. This is between us and the moon. These things here. And what that whole complex is there, I don't know. There's so much to explain now since this type of research that we're doing now. And it's because I got people that are just citizen scientists. They want to know the truth, and they're just being, here's what we're getting from NASA and places like this. This is just a little doodle somebody drew. But it's got the black, and it's got the white. They're coming around to understanding this, and it's showing the entanglement of the particles, yes. But that's as far as they get. for billions and billions of dollars. Plus, Bennu that they just came back with a sample of is amazing, and it is biological, and it is a heart. There's no question whatsoever about 100% certainty. This does not look good for them. When I say there's no question, there is no question. This is membrane. This is sarcomeres, which are muscle sarcomeres. This is another membrane, and this is another layer of muscle. And here's what the muscle looks like right up close. These little blocks are what they call sarcomeres. And of that, there is no question whatsoever. This is exactly identical. This is a sarcomere, and it has phosphate layers in between. The same thing they found, phosphate layers, and then the red muscle. Now, in between that red muscle, there's all this little connective tissue. It's exactly what they found. No difference whatsoever. So don't forget, there's no question this is a muscle from the heart. This white stuff is phosphate layers. They never expected that. This is the same picture without the filter to show the phosphates. But in this, there's layer after layer after layer, and then there's this bundle. You see this bundle right here? You ask any heart surgeon what that is. That's a bundle of fibers that wraps around your heart, and there's just now, when you cut that bundle, and you look at it, what's inside that bundle, there's heart sarcomeres, and you ask any heart surgeon if they're any good, they'll know that. And they'll know that there's a layer of membrane between every layer of sarcomeres. And there's going to be zillion layers of sarcomeres. They came back with this. They found DNA, they found RNA, they found uracil, they found 16,000 biological, atomic molecular bits. There's no question. It's everything. And it looks like a heart. I'm not kidding you. I am not kidding you. It looks exactly like it has the valves and everything. And so does Psyche. Psyche, you can see the tubes coming out of Psyche. Let me show you this. All right, this is about the mission to Bennu. How can we better understand? Well, let's see. This is National Science Foundation, Smithsonian, all the things that we're paying for, I think. All right, so they landed a lander on there and grabbed a chunk of this stuff and came back. When they spished like this, all kind of debris went, which was blood cells. This is the same colors as oxygenated and deoxygenated blood. Red, yellow, black. Red is oxygenated, yellow is in the middle, and black is completely deoxygenated. Hematite, magnetite, and whatever the other tite is. All right, let me just show you something. This is what a heart looks like. That is a heart, and that's Psyche. That thing's a monster. Now, these are the valves, and these are the valves. This white stuff here is this right here, which is the tendon that holds the muscle into the fabric. All right? These colors are the same colors I just showed you, the red, black, and yellow. That's blood. And it's all over this thing. This has tubes coming out of it. Now, that is the same as Bennu. And then you say, well, why would it be down here? What happened to all that stuff? That stuff pops off. And it pops off because of what's called iron banding. The red and the blue don't like each other. Pops right apart. And it happens even in autopsies. You see that? That's not CGI. That is an actual picture of Psyche. And you see the tubes coming out of it? Doesn't anybody notice this? Tubes coming out over here. You see the color? These are the colors of blood. It's exactly what I just showed you. And Bennu is exactly the same architecture. It's a little more scruffy. This one here, you can see it better because it's much bigger. This is 140 miles. Across 140 miles. This is tendon. This is blood. These are the valves. These are tubes coming out, and the top is gone. Tendons here. All right, now it's the same as Psyche. Psyche, you really can't. Psyche was what we were just looking at. This is Bennu. This is where they landed, and they looked at it and they saw all these boulders, and they're good size because this thing is good size. I think it's about 1/3 of a mile, something like that across. Much smaller than Psyche, but you see that circle there? Look carefully. That, I believe, is the center of the valve. And I believe that valve runs right around here. And the blood would come this direction, and if it tried to go backwards, it would seal that valve off. That's how these valves work. They have an open, the blood goes that way, but it can't come back. It's a gate. Basically, that's what they are. And then when they landed on there, they hit this thing with some compressed nitrogen. The blood went everywhere. Those little blood balls that were everywhere, and he grabbed a hold of the muscle. They didn't, and I couldn't believe. I knew they were going to come back with blood. I had no clue they would come back with muscle, which they did. And here it is right there. Here's muscle right here, and here's the muscle. I mean, it can't be denied, and it has every signature. I mean, there's nothing here that doesn't add up. All right, I'm going to leave it at that because I don't know where else to go with this. I've been calling this out over and over and over. And once you understand that everything is biology, everything changes. Everything changes. All right, and I'm serious. I mean everything. So sometimes you want to stay hidden and just forget about life. Well, that's up to you. I'm looking to see everything I can see. And the things that the people now that are working with me are so stunningly competent. It's unbelievable how life has gone on this long with the people that refuse to engage in reality. Right now, citizen science is the way to go. That's my feeling. When I say citizen science, you wouldn't even believe how many things I get that I just don't have time to work with. And a lot of them don't make any sense at all. I have to admit, I am a material guy. If you can't show me and really prove to me the way I prove to people things, then I can't accept it just and jump into a whole lot of research about something that doesn't have a really hard material core. Once you got a hard material evidence, then I have to explain it. And so far, I've been able to explain virtually everything using dipole electron flood theory. It just works for everything. And you can see them. They're just everywhere. It's not like it's not there. It's very easy to see. And all of these fields are things that they're flowing through, light and so forth. The universe is just expanding and the light is slowing down because it's being pulled. No, light's slowing down because of all the stuff that's in front of it. And there is so much stuff in space that's in front of everything. You can't tell me light goes through there and never slows down. It's just not, it doesn't make sense. All right, so I'm going to leave it at that. I think I've made my point, and I think quite well. If you have any other opinion, I'd like to hear. If I didn't make anything clear, I'd like to know what not. And I'd like to have somebody engage with Mason and myself and people like Dylan and Rod and all of these people that are coming to me because they have no place else to go. I'm just a loudmouth, that's all. I had my own research and I can stand by it and they can stand by theirs. And theirs supports mine and mine supports theirs. So, and Velikovsky was destroyed, and I don't think that's the right way to go because he showed things like we're showing that are just outside of the realm of what everybody thought was possible. The Mudfossils changes everything. I mean, way everything. And then when you see all these things in space are just gigantic biology also. Well, we got to start over and start to think again. What is it? Is there any meaning to this? All right, you stop and think about it. Is there a meaning to you? Maybe not. I have people say, what am I going to do about it? There's nothing I can do. And, I can't disagree with that. Although, I think this opens up a door to what may happen to us after we pass on. That's totally misunderstood, or not understood. Let me put it that way. I don't know anybody that really understands it. If they do, I'd like to talk to them, but I don't want to hear something that has no material substance to it. I go back to the ancient texts at this point. You do anything you want. I'm going to leave it at that. I love you all. Stick with me. We're going to research our little brains out until we understand what's going on. Then go about your life. All right, love you. Bye.